What's up? Today we are going to learn how to solve exponential equations. So we need to think about the structure of an exponential equation before we can get started on solving them. So recall that in an exponential equation, right, the variable is in the exponent. And so because we don't currently know any inverse operation that will remove that variable from the exponent, we have to think of another way to isolate the variable, right? Get it by itself. So I want you to consider these equations below. So here I have 3 to the x equals 3 to the second. So you're probably thinking, oh, well, x has to be 2. That's the only way that makes sense. And so if we plug that back in to check our work, right, does 3 squared equal 3 squared? Well, of course that works. That's a true statement, or it's known as an identity. And somebody would say, that works. All right, well, what about this one here? A little bit more complicated. I have 3 to some power equals 3 to some power. If I set x plus 1, that first exponent, equal to 6, and solve, if I plug that back in, am I going to get a true statement? So this would be 3 to the 5th plus 1. We know that that is equal to 3 to the 6th. So what we kind of uncover here is what's called a common base, and that's how we're going to solve exponential equations in Algebra 1, and then in Algebra 2, we're going to get a little bit more sophisticated with how we can solve them. But for right now, if a to the m is equal to a to the n, right, then m equals n. So this is called solving with a common base. As long as the bases are the same, right, a to some power equals a to a different power, we can set the exponents equal and solve. All right, so let's check these out. I've got 5 to the x plus 1 equals 5 to the 4th. So I'm going to set my exponents equal. So if x plus 1 is equal to 4, then I'll subtract 1 and I'll get x is equal to 3. All right, well, before we get too excited, let's check our work. So 5 to 3 plus 1, is that the same as 5 to the 4th? Well, yeah, right? 3 plus 1 is 4. So we know x equals 3. Works out here. Next, we have 3 to the 2x equals 3 to the 6th. If I set my exponents equal, like so, I'll have to divide both sides by 2. To get x alone, I get x is equal to 3. So we have 3 to the 2 times 3. We're hoping that's going to be equal to 3 to the 6th. And of course, 2 times 3 is 6. So this one works out. All right, next, we've got 7 to the x minus 3 equals 7 squared. So if we set those equal, we've got x minus 3 is equal to 2. So if I add 3 to both sides, I'll get x is 5. And then again, we should check our work. So if this is 7 to the 5th minus 3, hoping that that's going to be equal to, these are question marks I'm drawing, by the way. Okay, well, that one got kind of ugly. It's equal to 7 squared. Of course, 5 minus 3 is 2. So this one works out as well. Not so bad, huh? Something else to consider is that if your equation, right, doesn't currently have a common basis, we might have to make common bases. So what I mean is that if your equation doesn't currently have common bases, you're going to have to use those properties or laws of exponents to rewrite the expressions. And you might have to rewrite one side, you might have to rewrite both sides of the equation. So let's see what this looks like. If I have 8 to the x is equal to 2 to the 6th power, then I've got 8, I know I can rewrite as 2 to some power. So what I'll do is instead of 8 to the x, I'm going to replace this with 2 cubed. And that's equal to 2 to the 6th. Now the properties of exponents need to come into play. So here I'm going to take 2, I'm going to multiply those exponents because it is a power to a power. So let's think about what we did here. So first, I'm going to color this different color. Let's make that green. All right, and the reason I did that is to show we took, oh, gotta go back to the pen. I took 8 and I replaced it with 2 cubed because those are equivalent, so I was able to substitute. Okay, so now I substituted first, right, and then here I used the property of exponents, right, power to a power, or power of a power, however your teacher meant. All right, to simplify. So now I finally have that common base, right? 2 to some power equals 2 to a different power. So now I can set my exponents equal. So I'll have 3x is equal to 6. Divide both sides by 3, and I get x is equal to 2. Now make sure when we're checking our work here, we're going to plug it back all the way into the beginning. So we'll have 8 squared. I'm trying to see if that's equal to 2 to the 6th. So 8 squared is 64, and so is 2 to the 6th. So we know x is 2 is our solution. All right, so let's keep going, solve a couple more equations. I've got 9 to the x minus 1 is equal to 3 cubed. All right, so 9, I know I can replace 9 with 3 squared. So I'm gonna still have this exponent here. Then replacing 9 with 3 squared. Now I need to take care of those exponents. Again, this is a power to a power, so I'm going to have 2 times x minus 1. Notice I use parentheses here because I'm going to have to distribute that 2 to both terms in that binomial. Now I can set my exponents equal, and I'm going to go ahead and do my distributing at the same time, but you, of course, can break that into multiple steps if that makes the most sense to your brain. And then I'm going to add 2 to both sides, and so we'll get 2x is equal to 5. X is equal to 5 halves. And you can always check your work in your calculator to save time and space. I'm not going to check the remaining 4, but you can always, like I just said, check in your calculator and double check, just to make sure, you feel confident in what you're doing. All right, next, utilize the fact that 16 is the same thing as 2 to the 4th power. So again, instead of 16x, I'm going to have 2 to the 4th to the x is equal to 2 to the 6th. All right, well, power to a power, I'm going to multiply, so this will become 2 to the 4x is equal to 2 to the 6th, or 4x equals 6. Divide both sides by 4, I'll get x is 6 over 4, which simplifies to 3 halves. All right. Now the next two are, the next one is going to have an example where we're going to rewrite both sides of the equation. So 4 and 8, I can both rewrite those as 2 to some power, right? So 4 is 2 squared and 8 is 2 cubed. So this is going to become the following. So we'll have 2 squared to the x plus 1, and we'll have 2 cubed to the x minus 2. So when I clean up with my power to power, making sure you use parentheses so that I don't forget to distribute. Sorry, I suffer from brain fog. All right, so now we've got 2x plus 1 is equal to 3x plus minus 2. And the reason I did that, right, I have these two bases to different exponents that are, I could put my exponents equal. All right, so now we're going to distribute. We have 2x plus 2 is equal to 3x minus 6. Going to subtract 2x from both sides. So we're going to have 2 is equal to x minus 6. If I add 6 to both sides, I'll get x is 8. All right, last problem, guys. So I have 64 to some power equals 8 to some power. I could rewrite, since 64 is a perfect power of 2, I could rewrite both sides, but I don't have to. I'll just rewrite the left-hand side using the fact that 64 is 8 squared. So this will look like not 64, but 8 squared to the 3x minus 4 power is equal to 8 to the 2x plus 1. Again, we have power to a power, so this will become 8 to the 2 times x minus 4 power equals 8 to the 2x plus 1. I'm going to set my exponents equal to each other and distribute. So we got 6x minus 8 is equal to 2x plus 1. We subtract 2x from both sides, so I'll have 4x minus 8 is equal to 1. If I add 8 to both sides, I get 4x equals 9. And that means x is equal to 9/4. And there you go, guys. We solved some equations with a common base.